Hello guys, welcome back to my channel. So today I'll be explaining about computing power in mathematics topic. So let us start with the definition. And what is computing power means it calculates raised to the power of n, a power n efficiently. So nothing but 2 power n, how to find 2 power n, I mean 2 power 2, 2 power 3 like that. Okay, so let us take a real life and practical example. It is mostly used in encryption and reoccurrence relations, etc. For example, if you want to find 2 power 10, then it is equal to 1024 used in memory sizes like KB and MB. Oh, this is mostly used in encryption and that kind of examples. And in this, there are two approaches. First one is naive, and second one is binary exponentation. I'll be explaining the binary exponentation, which is very efficient approach. So first one is multiply. First naive approach is nothing but the big of n, where it multiply itself number of times, and it takes a lot of time. And coming to binary exponentation, it takes big of log n, where it actually chooses the less amount of time, which reduce the power by half each time by using binary exponentation. I'll be explaining this code and try run in the end of the video. Now coming to time complexity and space complexity, where naive approach takes big of n and space complexity is constant. And coming to binary exponentation, it takes big of log n, where it divides. I actually told in the previous video, whenever we divide something, then we will get the answer as big of log n. I mean in time complexity. And space complexity is big of n, where it is constant. Sorry, big of 1, where it is constant. And coming to interview style answer, how to answer means, here to compute a power n efficiently, I use binary exponentation. You need to say like this: to compute a power n efficiently, I use binary exponentation. I square the base and halve the exponent to each step. If the exponent is odd, I multiply the result. It turns in big of log n time and is used in the modular arithmetic and cryptography. Okay, this is how the sample answer looks like, and I'll be explaining the code and diagram in the end of the video. Now let us see that.
So now let us see the dry run of computing power. So I took x equal to 3 and n equal to 5, where 3 power 5 is equals to 243. This is what the answer we will get. So now let me write the conditions. So int result equal to 1. Let us keep result equal to 1. If while greater than 0, then it will enter into this loop. So here n should be greater than 0. Okay. So if it is true, then if n and 1 equal to 1, then it will enter into another loop, result equal to result into x, and x equal to x into x, where it shifts n greater than or equal to 1 after at the last. Okay, and then after that it will return the value. Return result. Okay, first n should be greater than 0, and after that n and 1 equal to 1 means then it enters into this loop, or else it will not enter and it becomes false. So here n is greater than 0, however I got n is equals to 5, so it is greater than 0, then it will enter into this loop and it checks here n and 1 is equal to 1 or not. Then after that it goes to result equal to result into x, and x equal to x into x, n shifted on the right side with the one value. So now let us see the diagram, and this will be completely based on this AND operation, right? So that's what I wrote, this AND operation. This is what AND operation. If 0 1 or 1 0 or 0 0, then the value is 0. If only 1 and 1, then it becomes 1. So now here, however, n is greater than 0, right? 5 is greater than 0. Now let us only write n and 1 value we will be checking. So 5 1, so 8 4 2 1, so 0 1 0 1 0 0 0 1. So here 0 0 0, here 1. Yes, it is equal to 1. N and 1 is equal to 1. So this is true, right? And now it enters into this loop. It is true now. So result equal to, actually I mentioned result as 1 before here. So 1 into, what is the x value? 3. So 3, that is equals to 3. Okay, so result is 3, and x equal to 3 into what is the x value? 3 into 3, that is equals to 9. So this is what the answer. And now, so at the end, we need to shift this value. I mean, n value we need to shift it. So 0 1 0 1 here, this is n equal to 5 because I'm doing this condition here. We need to shift it one aside, so we will be getting 0 0 1 0 because this goes out and this comes here, here and here. So 0 0 1 0, this is 2. Now n is equals to 2. Now again n is equals to 2. I got this is the n value, and n and 1 is nothing but 0 0 1 0 and 0 0 0 1. So 0 0 0 0, we got answer completely as 0, right? So it is not true, so skip n is equals to 2. Okay, now let us see x value. Previous value x is equals to 9 because it doesn't I mean it is not satisfying this condition, right? It is not equal to this condition, so we need to skip this. So x is equals to n into n, that is equals to 81. And now again we need to skip n value. So actually we will be getting 0, right? So we need to shift n greater than okay, so we are having n is equals to 2, right? So we need to shift 1 aside. So aside 0 0 0 1, so we will be thrown outside this and we'll be getting 1. So 0 0 0 1, so n is equals to 1. Okay, so n is equals to 1. And now 0 0 0 1 0 0 0 1 0 0 0 1, so is equals to 1. It is satisfying. And now result becomes, actually in the previous video result is 3, right? So 3 into x, what is the x value? We got 81. So 81, that is equals to 243. So I got 243. And that's it for the video, guys. If you like the content, please hit the subscribe button for more videos, and see you in the next video.